Okay, here we are again. I've been messing around with some network troubles, so let's see if this works. Because you never know where Google is. Oh yeah, okay, we've got internet back. Okay, I hope I can interrupt it, but we'll see how that goes. Alright, we're online. We're on the internet. Come on, go down. So there's lots and lots on my to-do list. And it doesn't involve, like, pinging Google all night. So, welcome to episode N+1 of this fun series. The goal here is to play with this machinery and use it in action with real modern computing, and yeah, we'll see how that goes. Hey Luna! Oh, you can't watch, oh no! Well, thanks for checking in the chat. Really good to hear from you. And you can always catch up later, it'll be on the Twitch videos. So, I should figure out how to stop this thing. Because I can just kill it from the other terminal if I SSH into the machine. But then there's probably some enormous buffer full of ping messages. My Control C is not really working. I gotta fix that somehow. I don't know why Control C wouldn't work. I think it should send the actual character through. Of course, there's lots of layers of compatibility here, so that's part of the fun of dealing with old machinery. There's a terminal keyboard, produces basically 7-bit ASCII with a uppercase only, without many of the symbols you're used to. That sends it through a current loop, which is a serial protocol. And the current loop ends up in a little piece of electronics that I'm going to show you later. And then in a teensy microprocessor that does some interfacing, and I'll show you that. And at that point it might be losing, like this Control C should be like whatever's numeric code that is. My teensy might be translating it wrong. Who knows? And then I might not even have my Unix terminal that I'm connected to kind of recognizing Control C as an interrupt. I killed it, honestly. But it's obviously got a large output buffer, and there's buffers in the teensy as well as in the terminal output. There we are, killed. Boom. Yes. Alright. So that's what happens if you run away with a teletype. The old-fashioned way of fixing that is actually just to hold down the break key. And that's an interesting whole topic in itself. Every single thing on this, like the here is key, we haven't really talked about. The break key is like unheard of, magic technology. It basically cuts the current to the loop. And how does anybody know that that makes a difference? Well, the loop is constant current. It's 20 milliamps. Voltage doesn't really matter. It's just pushing current down the wire. And it's a loop. So as long as the current keeps flowing, then nothing's happening. But everybody knows that the circuit is there. And the computer can tell that there's a terminal connected, even though there's really no data going across it, because the loop has got a current flowing in it. So then when you press like a key on this, the letter U is the one that's good for demo. If I had a logic analyzer, because U is basically alternate bits. It's 10 10 10 10 whatever. I hope there's no command called U. Python. Let's look at it in Python. Bin? I think it's bin. U. Now this is... Oh no, it's not bin. It's Let's do this properly. I'm going to talk about the letter U. You can see this on the banner of my Twitter page, and you'll see it. But let's see why the letter U is an interesting thing. So here we are. Yeah, okay. Let's put a variable. And I'm going to make it the letter U. Now what you can't see here is that is lowercase, because there's some case conversion going on. So if I say chord of this thing, this is the ASCII value, and in hex that'd be 75, and if you look that up on the ASCII table, then 75 is a lowercase u. Oh no, I can't even I can't even type the letter U. So that's not going to work. Anyway, I think if you subtract like 2 zeros from that and you get 55, then that's the capital letter U. Let's try it. 55 is the capital letter U. Okay. Then let's look at the binary of this. There we are. So the binary value for the letter capital U is a 1010101, and there's a leading 0 that got thrown off of there because it didn't get registered. So if you've got 8 bits, then the letter U goes 01010101, and that's great because it makes a nice little regular little pattern. Actually, let me character 55 times 20. Let's print a bunch of them and turn the tape on. And there they are. Doesn't that look nice? We have 10101010, but you've got to read it this way, right? Space and a 1 and a space and a 1, or whichever way. I forget which way the bits go. Anyway, so if you put a letter U, then the signal that actually goes across the current loop is first as a start bit. Well, so okay, first downtime. The loop is on. Hey, fair enough. Thanks for joining us. I'm just rambling about current loops. so the current loop is connected, and that means there's a current flowing in the loop. And when you press a key, it basically interrupts the current for a 1. I forget. Does it interrupt the current for a 1 or for... I think it interrupts the current for a 0. But it starts with a start bit that interrupts the current very briefly. And then you get, let's say, the letter U, which is 010101. Oh yeah, so it interrupts the current for a 1 or a mark, and it lets the current continue for a space. And then there's 2 stop bits at the end of it, which are current flowing, I think. Anyway, that's right. So the break key just basically disconnects the current completely. And so that would be like a start bit and then all zeros. But then if you hold it longer than it's waiting for the stop bits, then it knows that something's wrong. So basically, break here is like sending an at or something like that. It's like sending a null. Yeah, it doesn't like that at all. It's like sending a null signal, but if it lasts too long, then whatever's connected on the other end of the loop is expecting some stop bits, and they don't arrive, and you know that it's actually a break in the circuit. So break literally means break the circuit. And you don't see that in like other serial protocols. Today is a serial protocols day. I'm expecting... actually, today's a mess with the Wi-Fi day, but I've done that and I managed to get on the network. So I'm happy with that so far. But we're going to do serial protocols. So let me see. I have a to-do list. Let's get out of Python. Let's go to my home directory and into the directory of the GitHub repository that I'm using to track all this stuff. Look at the to-do list. And the first thing on the to-do list is what? The World Wide Web. So it came to my attention, and you probably noticed this as well if you're tracking like tech news, that this week is the 30th anniversary of something about the web. And that's a long time. And the web's important. Like it or not. So I'm going to talk about the web. And I think we're going to go on the web. We'll see. Then I've got a piece of hardware called Coral, and it looks like this. And I'm going to install it and play with it. Let's read the label. It says, a single board computer with an attached edge TPU, system on module, get started at g.co. It's Google hardware. And it's basically a Raspberry Pi style board with a machine learning optimized ASIC called Coral, or the Edge TPU, and it's designed for running like wicked fast machine learning. So this Teletype here is designed to connect to supercomputers, and I just ordered one in the mail, and there it is. So that's on the agenda for later, is let's wire up a new supercomputer to replace the old supercomputer. So the rest of the things on the to-do list are basically more on the Twitch bot. I don't know if we'll get to that. There's a ton more things I'd like to do with the Twitch bot. And of course, if you chime in on the chat, then we can take it wherever you want to go. I'm quite happy to just like hack on whatever. I do want to replace my local host, and that's a big job. So, right. First things first. How did we get here? This is the web. 30th anniversary of Tim Berners-Lee writing a proposal that says, "Hey, please fund my project. I want to write the web. I want to revolutionize the way that people share information these days." And I guess it worked. In different ways than he could have expected, but there you are. So let's talk about back in the day when this thing was current, like what that really meant, because it's really fascinating. And then we'll see if we can actually go on the web, but there's a lot to get through before then. So this machine dates to probably the late 60s. They were made from 63 to about the end of the 70s, but they were really obsolete by about 1975 when video terminals got cheap enough to replace them. So everybody threw these out because they're clunky and noisy and slow and smelly and unreliable, and they print on paper, so you can't move the cursor up and all of that. And so the video terminal got rid of these things by the end of the 70s, which is way before the web, right? I mean, we're talking like end of the 60s was 50 years ago. So these things were current 50 years ago. And this machine, this actual one, probably dates to 50 years old. It's the kind of machine that was connected to a computer. And that might be a huge computer, right, with 100 of these terminals connected to it. It might be like a mainframe, essentially, or a supercomputer, or it might be a mini computer, such as the ones that digital produced in the 60s and 70s, like the PDP-7, PDP-8, PDP-10, PDP-11, and all of those things. Or it might be a microcomputer, which was small enough to fit in a box. That mini could fit in a half a room, or it looked like a filing cabinet, maybe. A microcomputer was an order of magnitude smaller than that, and of course they came out starting in the 70s. But none of those computers typically were connected to anything else. So if you had, like, we talked last time about social networking in a single computer, and actually you can do that today. You can like connect several people to the same computer and then just send messages to each other's terminals. You can chat, and that's kind of cool. But it's local area chat. It's not like a wide area network. The computer is in the middle, and there's just one of them. And that's the situation here. I have this machine, and if I look at who's logged in, then I'm connected to a Unix machine. It's actually a Raspberry Pi, and there's probably 2 users with the same name connected to it. I hope there's nobody else, so this is me, ASR33. The terminal is ACM0, and that's actually a bit of USB-ness. And then there's another user logged in through SSH from a network address. But essentially that SSH connection is just like a physical wire. So it's like we've got 2 terminals connected to the one Unix machine, and there's only one computer in the picture. And so if we want to manage all the information in the world, finding it is easy. You just like sudo root and use the find command, right? Or you could index it, maybe, or you could like create like shared directories and give people access to them and just say, if you want to share stuff with other people, put it here, and you copy it onto disk. So you put things in the temp directory or in some shared directory, and life was easy. And then suddenly there was more than one computer. How did that happen? I mean, like from day one there was more than one computer, but like they were connected together. And so in the old days of them being connected together, every single one was different. And there's a bunch of them that I can connect to here with like telnet across the network, and basically you connect to the machine and log in. If I want to connect to actually there's a few of these in here. In the bin directory underscore something, there's a few basically expect scripts, little connection scripts that connect me to different places, and there's a bulletin board system that Fostex runs. There's a CDC 6500 mainframe that's in Seattle, and we'll connect to that sometime. There's a HP 2000 emulator in Brighton. There's a Moo and Muds and so on. There's a Prime emulator. Most of the old stuff is just running emulation, but you can telnet to it across the network. But again, like, we're just logging into a computer. We're not doing anything different. We're just like, connect from here, but instead of connecting to localhost, I'm going to bounce off localhost and go somewhere else. And the web's not like that at all, is it? Like, the web is a problem that happens when you get TCP/IP everywhere and lots of computers on the network. Then you need the web. Or you need something, right? Because you've got information that's all over the place, and all sorts of people everywhere are contributing to it. And you've got this information everywhere, and how do you leverage that? What is the operating system for the network? Right. Now, I'm a little bit opinionated about the operating system for the network. And I'm going to show you why. Let me show you this. This is like the dumbest editor in the world, sorry. But it was written 50 years ago, and it's still perfect. It has when you load up a file, it loads it all up and it puts you at the end, and then you can move to line 1 just by saying OK. And then I can append some stuff, and I'm going to talk about Gopher, so let's do that. And then I can move line 1 to the end, and then I can go to the end, and I can change the start of line character, which is one of these, to a dot and a space, because that's my shortcut for saying, hey, I'm done here. And I can print it, and then I can write this thing, and I've just done a whole lot of like interactive, sending a command, changing the state of the model, really interacting with the thing on a very low bandwidth connection, right? This 10 characters a second, lowercase only or uppercase only, whichever way you want to look at it. Text in lines. It's the interface is clumsy, but the expressiveness of the language that I'm using to talk through the interface is really pretty wild. And then you get like pipes and all of that stuff. The thing I looked at earlier was I want to look at ifconfig, and I want to grep for the word inet. And this machine doesn't have a pipe character, that came later, but I can do this. And it's like I'm composing a command from a series of nouns and verbs. It's a real language, and it's real super expressive. And the shell, I mean, I'm not a big fan of bash, but it's super expressive. And so what's the equivalent of that for not just dealing with services and processes on your local machine, but for dealing with all of the information in the world? What is the equivalent of something that lets you compose like that? And what's the nearest thing that's like as powerful as a command line? Because this command line is wickedly powerful, even though the physical interface for it is kind of primitive. So, I mean, one answer. So that's like a problem statement, right? Like, why can't we use command line of the world to find stuff and to go suggest changes to stuff and to work together on stuff? And like, what is that command line of the world nowadays? And I'm not sure that it exists. And then there's another style of interaction, and that other style of interaction is kind of like menus. And so actually building menus is pretty easy, relatively. relative to building expressive command lines. And it turns out that one of the most successful and useful ways of navigating information across multiple computers was a menu system. It's called Gopher. And with any luck... Oh no, I installed Gopher on this thing. The default, like, Linux Gopher client on Debian, just by installing it from apt. And it doesn't... It assumes that I have a graphical terminal to use Gopher. I think it's in here. Yeah. There's a project called CGO, which is up on GitHub somewhere, and it's really small. It's just a C program. But CGO is a Gopher client, and hopefully, I built it, but hopefully it'll work on a terminal. We'll see. So CGO is like browsing the web from a terminal, but it's a Gopher client, and Gopher is really just menus. So what does that look like? I'm going to go to the Gopher site called sdf.org, and it works. All right. So SDF is still running, and it's been offering Unix services to the world forever. And go send them some money so they keep running. They have a Gopher site, and as you can see, they offer free and inexpensive membership for people interested in the Unix system, dating back to the late 70s. So this is like it behaves like a website. It's basically, let's go fetch some text. But there are two things that you can have in Gopher, right? There's text, and then there's links. And the links are basically kind of hierarchical, so there's like a menu. And once we get through the header text that describes what SDF does, which is totally worth reading, then my Gopher client, CGO, is reading all the links that are on the SDF site, and on the SDF home Gopher page, and then presenting me with a list of them. And my CGO client actually numbers them like A to Z, so AA, AB, AB. These are like hyperlinks. But this is, Gopher dates slightly before the web, and was starting to get pretty popular when the web came along. And it's way less flexible than the web, but I don't think you can really understand the web and its history unless you know a little bit about Gopher. And it's like, how did we get into this mess? Well, because people had things like this, which is actually a pretty sensible solution for, let's present a set of links to go find stuff so that I'm not actually logged into the SDF computer. I'm just going fetching an index from it, and then from that index, which is kind of the root at sdf.org port 70, I'm going to choose AE, and then it'll go fetch whatever that link pointed at, and it's another menu. So this menu says basics. It'll talk about SDF history and Unix basics, chat, dial-up, etc. It's not super interactive, but totally browsable, like menu system for all the information in the world. And it links things together, not just on this site, but across sites. So some of these links might take me to other resources that are somewhere else. And so that was kind of the beginning of URLs and URIs, and I mean before they were really defined like that. That these links might take me to somewhere else in the Gopher space. And then there were indexing like systems. So the equivalent of the Googles today were like the ASCII index that would basically crawl Gopher sites and FTP sites, and build an index of all the words in them so that you could go like search Archie and it'll tell you where stuff is. So this is like an application layer above all of the computers in the world, connected over this very, very simple protocol, Gopher. And Gopher is really, I mean, it just give me a text file and there's a markup style thing inside of it that says this is a link and this is where it goes to. So if I pick like AA off of this list, actually, so I picked AE and that took me to a place, and I think next down here it's going to tell me like the address of the place. SDF/FAQ. And then if I go like AA, which is my basics link up here, I can browse further. And it tells me all about SDF. So this is kind of useful. I can move around the place. It's like, it's wicked. And it's a little bit primitive, but it's actually highly effective, considering that. So this Gopher dates, I guess, to the very early 90s or the very end of the 80s, when there were Unix networks, and when dumb terminals like this one were still pretty common, or at least visual versions of this, and these were still, like, you'd occasionally come across one of somebody who hadn't managed to throw it away yet. But this is a real different style of finding things, and it's not a very good style of controlling things than my command line, right? My bash command prompt, where I've got huge expressive power. I've got a learning curve that's like the side of a mountain, but I can do anything. What is common sense, and how do I use it? What if I get my parser? Why does backspace and delete not work over here? This is going to go on for a while. But I think you get the sense of this. Let's go for it. It's a list of menus. And I think some of my least favorite apps in the world are a list of menus too. So there's your contrast, right? There's like the command line versus lists of links. And actually Gopher was hugely successful and only got ousted by the web for some reasons. Let's quit with Control D. But Gopher was is still around. I mean, as you can see, there's maybe a couple hundred Gopher sites still up and running in the world. Not that anybody uses them, but there you go. And then the web came along. Thanks, Tim. This week, 30 years ago, when he started actually working on this thing and put together the proposal and started like building software. Eventually, I think by a year or two, like I think August '91. I might be wrong about that. But the first version was like launched to the world. So what's the web? Well, everybody knows what the web is. It's like this, but has a couple genius things in it, and it has a real protocol for how to go talk to the server, more than just kind of give me the data. It has headers and it has body and it has verbs and so on. So the HTTP protocol was part of the web, and then there's HTML, and HTML is not just a list of links; it's a whole descriptive like language. And the first browser, well, the second browser was for line mode. So let's go look at that, because I installed it. There is a line mode browser. It's quite hard to build. You have to build it, as far as I can say. Binaries are not readily available for modern platforms, but you can just like clone the repo and go build it. It's not that hard. And the line mode browser is designed for people who are running terminals like this one, who haven't yet got with the graphical, like, hey, yeah, exactly. But even Lynx actually is not really line mode, because Lynx is like screen mode. Lynx assumes that you have a visual terminal, whereas the line mode browser doesn't even assume that. It just does like a line at a time. But let's see if it works. I don't know if it does. But and of course, the place to go to is CERN. Oh, let's try that again. Yeah, I want to quit. No, I didn't want to log out. Whoops. Let's log all the way back in. To my local host. And I think I needed to put HTTP. Right, let's try it. www. HTTP. //info.cern.ch. Let's try it. Isn't this great, by the way? It's like, isn't this fun? It's ridiculous. It's ridiculously fun. Like, seeing this thing pull itself around and then wait for it, it goes whoop! And the little hammer that's banging against the head of this thing, and the ribbon, which is actually very fancy silk ribbon, and the tape punch that will like punch you mass storage tape for when you need it most. Like the whole thing is just like, how did that even happen? So look at this. It says info.cern.ch. From here you can browse the first website, bracket 1. Browse the first website using the line mode browser simulator, bracket 2. Learn about the birth of the web, bracket 3. Or 1 dash, I don't know what the 1 to 4 thing is. Quit or help. So I'm going to type 1 because I want to go browse the first website. And oh, I think it's just like, yeah, I think it's working. Yeah, so we are on the first website. And it's a wide area hypermedia bracket 1 information retrieval initiative aiming to give universal access, and the line breaks are due to my weirdo line mode browser. Universal access to a large universe of documents. Everything there is online about W3 is linked directly or indirectly to this document, including executive summary, brackets 2. And so the line mode browser, I think, is actually kind of a backwards thing and always was. Because in a lot of ways, Gopher's better. If all you have is a line mode terminal, then browsing the web is really difficult. Because there's no clear separation between like what's a link and how do you, like, the web is great if you can point and click, and I can't point and click because it's a line mode terminal. I'm gonna produce an executive summary of the project. Yeah. I have a line mode terminal, and the web is really not suited to it, despite, like, you can still access it with ancient and slightly flaky software like this. And that's interesting in its own little way, but it's not, like, productive, because it's a bad simulation of a menu system. It turns this, like, hypermedia that's designed for a graphical UI where you can point and click into a line mode thing with like square brackets to tell you could choose that menu. And the Gopher layout of just giving you actual links and saying, like, deliberately this is your menu options is in a way better than the web if you're using a terminal. Isn't that funny? And I think I already ranted a little bit and said, like, in a way, having a stupid menu where you've got to wait for the whole thing to print out before you decide, like, oh, okay, my sphere of action here is to choose a number between 1 and 10, right? That's stupid in comparison with a command line. You've got the whole of, like, this modal command editing surface that is still there for a reason, because it works, because it's the most expressive tools for manipulating stuff in the world. But the web came about at this time when, like, everybody was moving to graphical, not just even kind of visual terminals, but graphical, like Windows and X window and like things that you really could point and click with a mouse. And I remember my first experience with it, which was one of those experiences, dialing up, looking over somebody's shoulder in a cube while they dialed up their local ISP, and these slow progressive JPEGs that launched, and each of them linked to somewhere else, and then there was the Louvre and endless.horse. I don't know endless.horse, is it any good? And the web's amazing, but it's not really amazing on a command line terminal. It's like, yeah, Gopher's better. And then the command line. I'm back at the command line, and isn't that great? I'm back at the command line, which is so much better than everything. Or at least for the purposes of this hardware. If you're going to connect to something with a line mode machine like this, then you want a command line, and that's what we've got. So I've been like fuming about this for all week. With the anniversary of the web, which of course is super important, and it's defined the way that everything works these days, and it's like the web has changed everything. But at the same time, I've got this niggling feeling that the command line for the universe still doesn't exist. We have a command line for a single machine, and I'm going to have to open a browser and go to Endless Horse. Why don't I go here? This better be safe. Taking random links from people in chat. Oh no. It's going to be really bad. Oh, I see. There we are. Yeah. My browser is not smart enough to even really understand things like that. Okay. Well, that's fun. I'm going to kill this from a distance. Because who knows what would happen otherwise. And it's also kind of interesting, the ASCII characters that you might want to display in Endless Horse include the vertical bar that doesn't really exist, and the underscore, and the underscore prints as a back arrow on this thing. Yeah, so anyway, that's my little bit of retro history for the day. Hope you appreciated. The command line is still like the best way to work with a Unix machine, or at least it's the most expressive little language because it's a language. And then now we're in point and click land, and the world has completely changed, and you've got more powerful expressive interface technologies, but I don't think we've got the command line for the world for the networked experience. And maybe this little project is going to persuade me to build it. I don't know what it is. Alright, so what I'm going to do here is now switch tacks a bit. I got this in the mail. It is a single board computer with an attached Edge TPU system on module. The reason I got this in the mail is because I put my credit card into Mouser. They sent it to me. Because, well, so the machine that's been running, that I'm locally connected to, my local host, is a Raspberry Pi, and it's very old and slow, and I need to upgrade. Let me show you the Pi. See if this works. Let's see, how does this work? This box here. Oh, there we are. This box here contains, and usually it sits in the pedestal of this thing, but I've hoisted it out of the pedestal so that we can go mess with it, and it's got a couple things in it. This little piece of electronics there is very hand built, and tomorrow's 3.14. Yeah. Time to start baking. So yeah, this is the current loop interface. There's a couple opto isolators, just because that's the right way to build a current loop interface, and there's basically a current power supply. Then on the other side of it, I'm gonna get tangled up in wires. On the other side of it is a teensy, and I don't even think I can. There, you can almost see. There's a teensy microcontroller chip, and that's doing the USB interface. So basically, that whole thing there with the two boards is current loop to USB serial, and that converts my Teletype's 20 milliamp current loop into something that a modern machine would expect, which is USB. And then the USB from it goes into a Raspberry Pi, and this is a nice but very old Raspberry Pi. It is a 2011.12, which is just about the oldest that there is. So I need to upgrade it, and I thought, well, yeah, the Edge thing is kind of Raspberry Pi style, but let's read the specs on it. It's something else. So yeah, there's a web browser here that talks about the Coral Dev board, and how we're actually going to connect to it. The data sheet, and of course now browsing the web is like a really good thing. Oh no, my oh yeah, it's just like slow because I'm running OBS on this now. So let's look at the specs for this thing. It is an Edge TPU module, which is the custom proprietary Google hardware to do machine learning, and it is got a quad-core Cortex A53 CPU plus a Cortex M4. The M4 is what's on the Teensy as well, but I've got a quad-core CPU in this thing, and a ML accelerator coprocessor that runs like 4 teraops, like 4 trillion operations per second, and it has a crypto coprocessor and a gig of RAM and some USB and HDMI and 8 gig of storage, and yeah, it's really wild. So I think I'm going to unbox it and see if I can connect, because one of the things in the spec, it says requirements. What do you need? Well, you need a serial terminal. Well, I've got a serial terminal right here. I've got a serial console. Can I connect it to this thing? So let's do the unboxing business. It's tiny. It's just like pie-sized. Ridiculously powerful. Chunky heatsink for the system on module, which is like just a bootstrap attached to a board that doesn't have a whole lot on it. The CPU's on the module, the way I understand it. And then we have a port for the serial console that we're going to plug into. We have USB and Ethernet, and we have a couple more USB-Cs and audio and HDMI. And I don't need HDMI because I don't need HDMI. And then somewhere on it, oh yeah, on the back, there's a couple MIPI ports, one for a camera and one for a display. So if you wanted to plug in a little LCD, then you can just drop it in there. If you want to plug in a MIPI camera, so that's like phone technology, right? Boom. Okay, Google's AI principles guide all of our work. We hope that they will guide your work too. See them. So what's this for, right? I mean, the AI principles actually say do not use this to build a weapon system. And so I think that's a good thing. This would make a really kick-ass robotics platform, clearly. I mean, if you've got a TPU that can do 100 frames a second of face recognition or object identification from a camera, then you could use that to steer a robot. Or you could do pretty high-scale audio processing. You can do lots of classification, image recognition. Yeah, I think it's a mean machine. The stream is like a half a frame per second, no audio. No audio! Oh, I'm sorry. Because on my side, it looks like it's doing several K per second. So, Telephasic, you're... yeah. Anybody else seeing the same issues with the stream? Oh, okay. Zelinmo says it's fine there. That's good. That's good to know, because I did have... some of my early streams were really crappy. Yeah, I mean, hopefully the video will come out well afterwards, so we'll be able to go back and watch it anyway. Yeah, let's look at connecting this thing. So basically, it's a Raspberry Pi style machine, and it runs what Google is calling Mendel Linux. I think it's just a Google distro that they're wrapping up specifically for this, that probably includes like whatever it needs to drive to talk to the TPU, and because the TPU is an ASIC, application-specific IC, built for TensorFlow, Google's AI, ML kind of data flow language. So that's what the TPU is for, and I guess there's some special drivers in the OS that they're bundling with it. But we'll see. This port here says it's a serial port, and it says you can connect a serial terminal to it. So let me read this. I'm going to do this very slowly because I don't want to do anything completely wrong. I want it to work. I'm trying to basically transplant this and replace my Raspberry Pi with this thing. Before you begin, collect the following. A Linux computer. Got that. It's Raspberry Pi. A USB A to micro B cable. Well, I've got a box of cables and we'll find the right one. A USB power supply, a USB A to C cable. We've got one of those. I have a bunch of cables lying around. An Ethernet cable, no, but I have a Wi-Fi connection. You also need a serial console. That's this. And then they qualify it. Serial console program, such as Screen, PicoCom, or PuTTY. Nope. So I'm not going to do that. I'm going to use a real serial console, and it's a Teletype. It's the industry standard. So let's skip over installing Screen. It says you can connect a keyboard and monitor to the board. Thank you. We don't recommend... Oh, no, I don't need a monitor like HDMI. No, it's a serial console. It's a terminal. Get with the program. Right, who needs a monitor? So, the factory settings do not include a system image. Only the U-boat loader. Das U-Boot, which is, like, as I understand it, German for the submarine. So there's a bootloader flashed onto it, and when I connect a serial console here, it's gonna give me the bootloader, but then I have to flash onto it the actual OS image, and that is gonna download off the web somewhere. So before you begin, verify the following: the board is completely unplugged, not powered. The boot switches are set for eMMC mode, and I don't really know the details of what that means, but my switches look right. These dip switches are like down in there, and they're super tiny. They don't supply a microscope to go see them with, or a tiny pencil to go flip them with, so luckily they're in the right place. On, off, off, off. Okay, now flash the board. First, add a udev rule to your Linux computer so it can recognize the dev board. I'm not going to do that. I don't need to do that. I'm going to connect a serial terminal to here. Connect to the serial console. Use your cable, micro-B cable, to connect your Linux computer, no, my terminal, sorry, to the serial console port on the board. The orange and green LEDs on the board will illuminate, and the board should not yet be powered on. Okay. Now my Raspberry Pi is still running. I'm gonna leave. I'm gonna unplug actually my USB cable that connects the Teletype to the Raspberry Pi, because I'm gonna plug it in here. But then I find myself with a problem. The serial console is a USB, and USB is mysterious in its ways, because it's universal and it's serial and it's like ended. The endiness matters, and that's not right. That's weird. Oh no, that's a C. Let me find a good old-fashioned micro USB instead. I've got one of those. That might come in useful. Got to dig down in the box here. No, that's a USB-B. Nobody needs those anymore. That one, that's right, but it's the wrong color. It's I don't trust it. It came as the power supply to something, not as the data cable to something. I don't know how useful it's going to be. That one, that'll do. But, oh no, that's just a power only one, because I'm paranoid. Let's see what else. Somebody lent me a USB cable. Well, let's try the one. Let's go through the motions as though it's going to work. And then we'll find the physical, like, discontinuity that is staring me in the face already. So look, this is USB micro. I plug this in here, and I want to plug the other end of this into my terminal, and my terminal has a USB micro on it, not one of these things. And my terminal has a connection that's a it's like another one of these. It's a USB-A. So I've got this A to A gender thing in USB going on. So is there any USB experts in the house? Because this gets weird now. So I knew this was going to happen. So I looked it up. And I don't think this is going to work. Or at least, if it doesn't work, then I have a completely accurate hypothesis for why. But I don't yet know whether it's going to work or not. And I'm just going to find out. My hypothesis says it shouldn't work because what are the chances that this serial console port here is a USB host? Well, slim. And in fact, that's my guess, is very, very slim indeed. I don't think it's a USB host. And if it's not a host, then how can I connect a terminal to it? Because a terminal is definitely not a host. And there is no way that my little Teletype is going to behave like a host, because it shouldn't. So I'm going to try this anyway. I have a bag of highly illicit, non-spec USB gender changer, like on-the-go things, and they convert like B to C and A to B and back again and all this bizarreness. And I carry these around just in case they're ever going to be useful, and they haven't yet, but maybe today's the day. So I have a gender, like, this is strictly illegal in USB land, but I have an A to A gender changer, and it shouldn't even work. It shouldn't be allowed. Nobody should let you do that. But I'm going to plug it in and see what happens. And do I get power on the board? I do not get power on the board. Well, that was a short-lived little experiment. If I plug both of these things into... Oh, yeah, I plugged it into the Raspberry Pi and I do get power on the board. And that's a bit sad, actually, because... Of course, the Raspberry Pi is a host. Yeah. So what I'm going to have to do here, and I'll show you the physical connection so that you see it. So I've got both. Whoops. I've got both of these things. On the left is the Teletype, and on the right is the new Edge board, the Coral board, and they're both plugged into the USB host on the Raspberry Pi. And what I'm actually going to do is I'll log in with this thing, then I'll use Screen to connect to this board here and see if I get like a console. So I'm going to bounce as if it's USB directly into the serial console here, but it won't be because it's really going through the Raspberry Pi, and that's a little bit it's a little bit of a strange situation, but let's see how it goes. So that's my dev board. Let's log into the Raspberry Pi again. Well, let's zoom in so you can see it. And the board should not be powered on yet, it says. And it is like a USB orgy. It's inside out and backwards too. Very dangerous stuff. Don't do this at home. Don't do this in public. So it says do dmessage grep TTY USB. Let's try that. Oh no, I can't do the pipe sign. So instead I say grep TTY, and I can't do a capital U either. But I'm going to pipe that in from... Nope. Sorry. Grep TTY. Pipe in from dmessage. And see what messages we got. I've probably got a million. And I hope I don't have a million. But time will tell. That was a very long line. I don't know why it's quite so long. But it's a very, very long one. And console TTY1 enabled, so even the Raspberry Pi has actual, like a console TTY, because it's Unix. TTY AMA, I'm not sure what that is, but it's not me. CDC ACM, I know what this is. So this is the USB ACM device. which is the Teletype. So an ACM device in USB land is supposed to be something that behaves like a Hayes modem. It's like USB got it's so complicated. like the teensy microcontroller that is connecting my Teletype so that it can behave like a serial terminal is actually pretending to be a Hayes modem, and that's what ACM means. And of course it doesn't really implement any of the Hayes modem command set, because why would you? But that is TTY ACM 0, and that's where I am right now. I'm on TTY ACM 0. But there's also this other one, CP210X converter, now attached to TTY USB 0. And so it is. Okay. So now I want to do screen. I need to write the letters capital U, capital S, capital B, and my terminal doesn't let me do that. So on my other thing here, I'm gonna say echo TTY USB 0. No, actually, let's do this as a whole command. Screen dev TTY USB 0, and then it says 1150. In the instructions it says 115.200. Well, let's try it. Screen dev TTY USB 0. That's the edge board. 115.200. It's gonna be wickedly fast, but screen will adjust. We'll deal with it. I think it'll work. Okay. And then let's make that thing executable. And then from here, let's see if we can set up screen. Are you serious? You can't run screen on a hard copy terminal. Yes, I can. Well, I'd love to. Okay. I really, really want to connect to the console with my Teletype. And it's just, I don't need, do I have CU? What's CU? I don't have CU. I think I'm going to persuade it that I have a non-hard copy terminal, because I think that's the right thing to do. Oh, CU connects to a serial console. That's kind of cool. Yeah, I don't have it. I could probably get it. But I think I could do the brute force way, which is to go edit my term info file, and this is my custom kind of term info file, and it's basically the regular ASR33 terminal definition, but with a few extra things. But here it says hard copy, overstrike, and then all this other stuff. So on line 1, 2, 3, 4, I can just take out where it says hard copy. And then screen will let me start up. And if I get like anti-escape codes to go clear the screen, then like, I don't mind. I've actually got a clear screen command in here in my term info because we did that the other day. So I can say clear and it'll do that. So let's go to, oh snap, it's Kevin Mitnick. 1, 2, 3, let's go to line 4. And do I want to leave in the thing that says I can do overstrike? No, there's no need. Okay, so I have automatic margins and I have X on X off flow control. And then I can compile that. And then I can go back to here. And then there's this kind of screen command that I put in from the other terminal. That is too cool. Tip or minicom might also work if you have either of those, though minicom might reject a hard copy terminal too. Yeah, I mean, the hard copy thing is like anything that initializes curses is going to fail, usually. Really? It's going to go there. How about this? I can't do uppercase letters. So so let's go back to this SCR file that I've got here, and I'm going to insert the hashbang, because just in case, and then I'm going to say term equals X term, because like everybody's, oh no, term equals X term. Go to line 2, I messed that up, let's delete it. And there we are. It's going to pretend to be X term. Oh no! Oh, that's sad. Oh no! Yeah, I can do like the uppercase thingies, but this is like my cheating way. At some point, I'm going to build firmware that escapes uppercase letters for me. Cannot access line dev tty USB 0 for read write. I can't even do it there, so let's do it on here. It's owned by root. Well, maybe I do sudo screen. If I see a message, try quitting the screen program, unplugging the USB cable and try again. Well, I could. But I think it's worked. But I don't know why that terminal doesn't let me connect to it. Oh no, I don't need to do that. I don't need to do that. I just do sudo screen. Yeah. Yeah. It's waiting. It is blank. And I've established a connection in theory to this HTPU board over the serial console. It's got power. I can't really tell that it's got anything useful there. And now it says plug in the board. Plug in the USB port. Gunners Tem with the actual device name. Can you do something like bash from TTY to TTY to get a shell that reads and writes? Yeah, you can, or at least you can read and write directly to the TTY device if you are the same user. If you own it, or if it's group or world writable, and this is group writable but not world writable, so I think that's... Oh yeah, making sure that your user is a member of the dialogue group. I think that's exactly it, because I'm just in the wrong group. But I'm running screen as root, and I think that's okay for now. Let's boot it up. Okay, so this computer that I'm connected to right now is... Here's my power cable. Oh, I've got to figure out which is the power socket. Let me look at the instructions for a bit. Power socket is the first of the USB-C ones. So this computer is not booted. It's not doing anything yet. It is super powerful, but it's not booted up yet. All it has is a USB UART for CP210X, and I'm going to power it on. Wish me luck. Let's do it. Whoa! Well, something, actually a lot is happening. There's a fan. Holy moly! Holy moly, this is the bootloader. I wonder how long the bootloader messages are. Trying to boot from MMC1, which is the internal flash. Oh right, I think it's a computer. But this is really just the bootloader telling me that it's booting up. Yeah, it's one of the Google Edge TPU boards, and it's called a Coral, and it looks like this in the box, and it's a single board computer with an attached system on module to run machine learning stuff. So yeah, it's shaped like a pie. The CPU is a quad-core Cortex A57 or something. There's a Cortex M4 controller, and then there's this, exactly. It's a wicked little machine, I think. So let's see. Welcome to your new Coral Edge TPU development board.